Right, today we are going to do section 5.2, which is called fractions and decimals. Okay, so this is all, again, hopefully review, because I remember we just hammered away at this last year. So I'm hoping, again, that this will be pretty simple for everybody. Something I wanted to talk about is the difference between terminating and repeating decimals. So a terminating decimal is a decimal that doesn't we better underline not so we see that, continue or repeat. Okay, so an example of this would be like 0 and 721 thousandths, or 5 and 18 hundredths. Okay, so that is the end of that decimal. It does not go on any farther. It just ends right there. So then the opposite of a terminating decimal is a repeating decimal. Okay, so a repeating decimal is a decimal, probably you can guess it, where the same block of numbers repeats infinitely. Okay, so that same block of numbers repeats infinitely. Here's what it could be. An example, and, I don't know why that didn't work. 0 and 36 hundredths repeating. So what that would look like is 0.36363636. Okay, so a repeating decimal does not always have to repeat the same number. In this case, it could repeat two numbers, or it could repeat, it could be 0 and 759 thousandths. So that would be 0 and 759, 759, 759. Okay, those are all repeating decimals. They will repeat that 759 infinitely, forever. They will repeat on. All right, let's try converting some fractions to decimals. Okay, so the first one we are going to try together is 1/4. The best way, you guys, to convert a fraction to a decimal is divide the top by the bottom. So if I did 1 divided by 4, this will turn it into a decimal. Okay, so 4 goes into 1 0 times. 4 goes into 10 2 times, minus 8, left with 2. Add my 0, bring down a 0. Again, notice this. I remember last year we had some hard time because people wanted to put a 0 up on top and the answer 2. That is not what we do. We add a 0 to what's underneath our division bar and we bring that down. We do not add anything to the top yet. Now 4 goes into 25 times. Okay, so our answer would be 0 and 25 hundredths. Remember, we always divide the top by the bottom. The numerator divided by the denominator. We have to remember that because it doesn't look very nice to say 1 divided by 4. It doesn't look nice because 4 can't go into 1. So we really have to make sure that we don't switch it around and say the answer is 4 because we all know that that is incorrect. All right, let's try another one. 1 and 7/8. Okay, so for this one, we are going to circle up. Remember our friend circle up, where we do 8 times 1 plus 7. So 8 times 1 is 8. 7 plus 8 is 15. So my new fraction, my improper fraction, would be 15/8. Okay, so again, now I just do top divided by the bottom. Now this one looks a little bit better. I'll give it to you. This one looks a lot better. For this one, is I see that 8 goes into 15 one times. Too bad it wasn't one more in 16, then we'd be easy to go. Okay, so minus 8, I'm left with 7. Add my decimal point, bring up my decimal point so I don't get lost. Bring down my 0, and now I have to ask myself, how many times does 8 go into 70? Well, I know that 8 times 8 is 64, okay? And then I'm left with 6. Bring down another 0. How many times does 8 go into 60? Well, I know that 7 times 8 is 56. Okay, so I'd have 4. Bring down another 0. 8 goes into 40 5 times. Minus 40, and I get 0 left over. So my answer is 1 and 875 thousandths. Okay, so this one is a terminating. And this one is also a terminating. You have to look at the directions that the book says to see if they want you to say, is it terminating, is it repeating? You need to make sure that you're looking at that and not just saying, well, Mrs. Hamer didn't write if it was terminating or repeating on her video, so that means we don't have to follow the directions. Because first and foremost, read those directions. All right, I've got a few more that we're going to do here. Number 3 says 3 and 3/10. Again, circle up. 10 times 3 is 30, plus 3 would be 33 tenths. Do the top divided by the bottom. 10 goes into 33 3 times. Minus 30, I'm left with 3 over. Bring down a 0. 10 goes into 30 3 times. Minus 30. I'm left with 0. So my answer is 3 and 3/10. And this is a terminating decimal. So that is all we had to do for that one. What about number 4? Where it is 7/9. We do the top divided by the bottom. 9 can't go into 7. Let's add our decimal point and a 0 below our fraction bar. 9 goes into 70. I'm going to say about 7 times, which is 63. Okay, and I'm left with 7. Bring down my 0. I'm seeing there might be a pattern, but let's keep trying it. 9 goes into 70 7 times, which is 63. Left with 7. Bring down a 0. All right, so now I know that every single time I do this, for infinity, so forever, I'm going to get a decimal point of 0 and 7/10, where the 7 is repeating. I want you guys to get in the habit. Last year I would have accepted if you did 0 and 77 repeating. Okay, but this year I want you to see that just the 7 is the thing that repeats. So we're only going to take the first one number that repeats forever. The first two numbers, if it was like 75, we would only take 0 and 75 hundredths repeating. Okay, so I don't want you to do 7575 and repeat it, because that just isn't the way that we write them. Okay, so 0 and 7/10, this is a repeating decimal. Okay, let's look at one more. This would be number 5. For number 5, let's do 11/8. Okay, so let's see. A top, 11, divided by the bottom, which is 8. Well, that goes in there once. Minus 8. And I am left with 3 left over. Add my 0, bring it down. 30. 8 goes into 30 3 times. Minus 24. Left with 6. 60. 8 goes into 60 7 times. Minus 56. 8 goes into 40. 8 goes into 45 times. So my answer is 1 and 375 thousandths. This is a terminating decimal. And here's the deal, you guys. You might get sick and tired. Maybe you're going on for 10 decimals afterwards, but if that fraction is not repeating yet, or that decimal is not repeating yet, then you gotta keep going. I mean, something could be going off on your head. Man, did I do this right? Did I set this problem up right? Or did I do it wrong? But really, if it's going on forever, but it doesn't show a repeating yet, then it's not a repeating decimal yet. So you gotta keep going. I really hope they don't give you something like that, but I can't promise that they won't. All right, so now, how would we convert decimals to fractions? Sorry, Samson's barking at something. Okay, so how do we convert decimals to fractions? So let's say I have the decimal 1 and 75 hundredths. Okay, already in my fraction, my fraction, I'm going to know it's going to be 1. And I know that if I were to say this fraction out, I would say it 1 and 75 hundredths. So in my fraction, I know I can already put it over 100 because it's 75 hundredths. This is the tenths. This is the hundredths. Okay, so we know that place, it goes out to the hundredths, so I know I can put over 100. How many hundredths do I have? I have 75 of them. Now I just need to reduce. I know I can divide 75 by 25, 100 by 25, so I would get 1 and 3/4 for my fraction. Okay, let's try another one. Let's try 2 and 32 hundredths. So again, I already know my whole number is 2. So I can just write that 2 down. And I know that my decimal part is 32 hundredths. Okay, so now I have to say, okay, what can I divide the top and the bottom by? I'm going to go with 4. Divide by 4, divide by 4. Okay, so I've got 2. 32 divided by 4 would be 8. Oh, I didn't go far enough yet. And, yep, and then 100 divided by 4 would be 25. Oh, yeah, I did go far enough. Okay, so that would be our fraction, because we cannot reduce that anymore. There are no numbers that go into 8 and 25. So that one is good to go. Now here's the question that is going to be tricky. What about if I have a repeating decimal? What do I do then? Okay, now this is very, very difficult. This is the first time you've probably ever heard this in your life. So we're going to do 3 problems this way, and I really want to make sure that you're listening and paying a very close attention. Okay, so really, if this 7 goes on forever, we'd have 0 and 7, 7, 7, 7, 7, 7, 7 forever. We can't figure out what we need to divide it by. Or we can't, like up here, we said it's 32 hundredths. Well, this is 7,700, 7 million, 7 billion. We can't figure out exactly what it goes on because it goes on forever. So bear with me here. Okay, this is just a way that we can use math to solve. So, okay, what we're going to do is we are going to multiply this number by 10. Okay, because if we multiply it by 10, we know if we multiply by 10, we just move that decimal point 1 spot. So now what I've got is 7 and 7, 7, 7, 7, 7, 7. So if I subtract my original fraction, or my original decimal, 7777, I would get the answer of 7. Okay, so here's kind of an equation. We've been thinking a lot in equations this year. So if I have my fraction, which I have my fraction here, okay, and then I multiplied that by 10. That's how we got to here. And then I subtract my fraction right here, then I'm going to get the answer of 7. Okay, so really though, what I'm doing is instead of saying 10 fractions, if I subtract a fraction from the 10 fractions, I'm left with 9 fractions equals 7. Okay, let me move this around so I can write it more clearly. I apologize that this is not very clear here. Okay, so if I have 10 fractions, because really this is 10 times my fraction, right? So 10 times my fraction, and then I subtract my original fraction, then I am left with this last number down here, which is 7. Okay, so 10 fractions minus 9 fractions. What if I had 7x's minus x? I'd be left with 6x. Same thing goes here. 10 fractions minus a fraction would just be left with 9 fractions equals 7. Okay, so 9 fractions. Now if I want to figure out what my fraction would be, I would just divide both sides by 9. And let me move up again. I apologize. Oop, move that up, move that up. Here we go. If I just divide both sides by 9, I get fraction equals 7/9. Okay, so that's the reason why we do what we do. So really, this is 7/10. Okay, but I'm not going to change that into 7/10 because it repeats. I'm going to do 10 minus 1. So really, it is 7/9 would get this answer. Okay, so we'll do some more. And what if it's not tenths? What if it's hundredths? What if it's thousandths? Then what do we do? I will talk about that with you. Okay, so let's try another one. I'm not sure exactly what number this is. Let me see. 1, 2, 3. This one must be 4. Okay, so what if I have 0 and 54 thousandths repeating? Okay, I already explained to you why. So this time, if I had 0 and 54 thousandths, if I multiplied it by 10, then I would get, or sorry, I couldn't multiply it by 10 because I'll move it once. I need it to move twice to get that a whole number. Because this is 54, 54, 54, forever. So I need to multiply that by 100. Okay, so I would get 54 and 54, 54, 54, 54 forever. Then if I subtract it, so this is my 100 times fraction minus one of my fractions, my first fraction, okay, minus my fraction equals, because this would subtract it out to be 0, so I'm left with 54 here, equals 54. Okay, so now instead of 10 minus 1 fraction, I'm going to do 100 minus 1 fraction. So now I have 99 fraction equals 54. So if I divide by 99, I get my fraction equals 54/99. Okay, and I think we can reduce this one. We should be able to maybe divide by 3. 1 minus 3 is 24, 18. So then I would get 18/33. Okay, so this would be my answer here, 18/33. But again, this is why, you guys. So don't freak out if you're sitting here saying, what on earth is Mrs. Hamer talking about? I have absolutely no idea why she's putting in fractions, why she's timesing it by 100. This is our reason why we can do this. Okay, my repeating decimal here is 54 hundredths. So I can write 54 hundredths, but because it goes on forever, I can just subtract 1, and I can write it as 54/99. Okay, this is my answer if it's repeating, and this would be my answer if it was not repeating. So if it's repeating, we just subtract 1 from the denominator, and that will get us our new answer, except for we have to remember to reduce so that we write our answer in the correct way. Okay, so this one is hundredths, so we had to do 100 minus 1. Now what about if it's thousandths? Let's try one of those. Okay, so for number 5, what about if it's 0 and 213 thousandths repeating? Okay, so again, I can just write 213 thousandths, but it's repeating, so I have to subtract 1 from the denominator. So really, I should get 213 999/99ths. Okay, so this should be my answer. Let's see, is this top one divided by 3? If you add up all the decimal, or all of the numbers, 2 plus 1 plus 3, I'd get 6. Is 6 divisible by 3? Yes, so I could divide both of them by 3. That's why those divisibility rules come in handy from chapter 4. Okay, so 213 divided by 3. 3 goes into 21 7 times. 3 goes into 3 1 time. So I get 71 333rds. Well, we can't divide it by 3. We can't divide it by 9 because 7 plus 1 is 8, and 9 does not go into 8. So I think that's it. That would be our one. So what we have to do is we have to figure out what are the repeating numbers. This one's 3, so that means I need 1,000. Then we just do this minus 1 to the denominator. And the first two I showed you why we do that. And if that's not exactly clear, I can help you to try to understand it more. I'm sure that as you go up in 8th grade math, 9th grade math, 10th grade math, that will start to make more sense to you. But really, this is kind of like a trick, is just we have to subtract 1 from the denominator, and that will get our true fraction. Okay, there's one last piece to this, and that is comparing fractions and decimals. I know we had a terrible time with this last year, so really, to ordering fractions and decimals. Okay, so to do that, we need to convert all of our problems to the same type. Okay, so for me, it's easier to go from a fraction to a decimal because all I have to do is divide them. But, I mean, it might be easier for you to go decimal to fraction. It all just depends on what you decide you want to do. Because the reason why I like going to decimals is I can just look at them. Whereas if I go to all fractions, I have to make sure they all have the same denominator, so they have common denominators, and then I can compare them. So what about if I have a number? I'm going to switch to another screen here quick, but make sure you write this down in your notebooks because that's very important. That if there's some fractions, some decimals, we need to either make them all fractions or make them all decimals. Okay, so this is number 1 of this section, not of the whole thing, obviously. So I have 0 and 2/10, 4/5, 9/10, and 5/10. Okay, so I hear that they are all kind of tenths, except for this one, and I think it would be easy just to turn that one into a tenth. So what I'm going to do is I'm going to make them all fractions. Okay, so 2/10 would just be 2/10. 4/5, if I multiply the bottom by, if I multiply the bottom by 2, top by 2, I would get 8/10. Then I would get 9/10 and 5/10. Okay, they all have the same denominator, so I can just look at the numerators to see which one's bigger. So right away, I see that this is the biggest one, and I'm going to make sure that I write down the original number. Please, you guys, listen to this right now. Do not write down your converted numbers. Write down, we'll make a note, your answer must include the original numbers. Okay, because somebody else might convert these into decimals. So then when I'm correcting it, I'm saying, okay, well, are these decimals right or are they wrong? I can't figure it out. Okay, so that creates a whole lot of more work for me. Your answer needs to be in these original numbers up on the top. Okay, so I'm going to write, oh, it doesn't say from biggest to smallest, so we'll say from greatest to least. Normally it's least to greatest, but we're going greatest to least. Make sure you read those directions when you're doing your homework, because I don't want you to get some wrong just because you ordered them the wrong way, because this is kind of the easy step. So I'm going to write 9/10 is my biggest. Then it would be 8/10, but we need to write it as 4/5 because that was my original. Then it would be 5/10, which I need to write as a decimal. And then 2/10 would be our smallest. So here is our answer for that one. Now this one, it was easier to convert them all into fractions because I could see that they were all tenths or close to tenths. But that's not always going to be the case, especially in this next one. So let's try and figure out this next one. All right, so for number 2 for this section, our answers are, our problem says -1/8, -0 and 75/100ths, -1/4, and -0 and 375,000ths. Okay, now this one's a little bit trickier. This one I'm going to choose to go to decimal because I think decimals are easier when we're using bigger numbers. Okay, so -1/8, if I were to divide that, I would do 1 divided by 8. Okay, add my decimal point. 8 does not go into 1, it goes into 10 once. Minus 8, I've got 2 left over. Bring down 20, it goes into 22 times. Minus 16. Oops, I'm going to need to move this one up a little bit. Of course it wants to move that up too. Anyways, that'll be fine. Okay, so then I'm left with 4. Bring down my 0 again, 40. 8 goes into 45 times, minus 40, I'm left with 0. Okay, so now I can move this back down. Hopefully I can figure out how to get them exactly lined up. There we go. Okay, so I'm left with, well, 8 converted would be negative, -0 and 125,000ths. This one's already converted for us. -75/100ths. 1/4, let's do 1 divided by 4. 4 does not go into 1, but it does go into 10 twice. And 4 goes into 25 times, so this is -0 and 25/100ths. And then this last one's already converted for us. -375, oops, that's supposed to be 7. -375,000ths. Okay, so now what I like to do, because this really helps me visualize things better, is to order them and line them up with their decimal points. Okay, so if I do the first one, I'd have 0 and 125,000ths, then I'd have 0 and 75/100ths, then I'd have 0 and 25/100ths, and 0 and 375,000ths. I'm just going to add my zeros so that I can look at them easier. Okay, so the only part that we really have to look at is the part that's closest to the decimal point. So let's look at these numbers right here. So I have the number -1, -7, -2, and -3. The reason why I'm doing negatives is because all of our numbers are negative. Okay, so I have to think which one will do greatest to least. Again, graced. Well, I guess we're doing graced. All right, greatest to least. Okay, so which one would be the biggest number if we're thinking negative numbers? That would be this one, -1, is closest to 0. Okay, so this one is going to be my biggest number, but remember, we have to write our answer using the original numbers, not our converted numbers. So to write our answer, I'm going to write the biggest one is -1/8. Then our next biggest one would be this one, negative. Okay, so that would be this one right here. So it would be -1/4. Then -3 would be the next biggest one. Okay, so that would be this one here. That one's already converted for us, -0 and 375 thousandths. And lastly, it would be -0 and 75 hundredths. Okay, so this way, you guys, really helps me out a lot. And now what about if there were two numbers that were the same that I was looking at? Well, then I would write this one as 12. I just take 2 decimal points. This one would be 75, this one would be 25, and this one would be 37. Okay, so now again, -12 is the biggest because it's closest to 0, so I would choose this one. Okay, so if there are ever two decimals, that are close to, you have the same tenths place, then we just go to the hundredths. What if they have the same hundredths? Then we go to the thousandths. But we have to make sure we're comparing them all as thousandths and not comparing 7, or in this case, 1. Let's take our 1 to 375, okay, because that's going to look much different. Okay, so we have to make sure if we're comparing, we're either comparing all ones, all tens, all hundreds, all thousands, whatever it might be. All right, that is all that I have for you today. Again, I will be working on some practice problems in class tomorrow if there is something you didn't quite understand. And thank you for watching.